Hi, welcome to Nomis Academy. In this video, I will be teaching you differentiation using the first principle. If you haven't watched our previous video on the use of simple formula, please go and watch. In this video, we will be using first principle. So, first principle for differentiation. So what does the first principle says? Let's consider if y is a function of x, that is, y is equal to x. Let's take this our equation 1. So to use the first principle, we say y plus the y, that is the change that has occurred along with y, is equal to x plus the x. So we are looking for the y dx. We have to make the y dx the subject of the formula. If that is the case, then the y stays equal to x plus the x. Then this y comes to the other side. That becomes minus y. So recall that y is equal to x, right? Therefore, the y is equal to x plus the x minus x. The y is equal to x plus the x minus x. So this is a plus x and minus x. That means let's cancel this. So I'm left with the y equal to the x. Nothing is left, right? 1. So this is the y dx. The y dx is equals to 1. Because if we divide both sides by dx now, divide both sides by dx. So dx cancel the x. We have 1 here. So dx divided by dx is equals to 1. That means the y dx is equal to 1. So we just got our final answer. So this is how we can use first principle to differentiate whatever we are given. So let us take an example to see how difficult we can use this first principle to differentiate functions and even limits. So let's take example number 1. Example 1 says differentiate using the first principle. Differentiate y equals to x squared using the first principle. Now, to use the first principle, let's go into the solution. Please remember the steps we need to follow. So y equals to x squared. Then we can tell that y plus the y, the change in y, equals, here we have x squared. And remember, if it was just x, it would have been x plus dx. And now that we now have x squared, that would be x plus dx. Another x plus the x. So since we have x squared, this is going to be like this. So when we open this, let's open this bracket. Y plus the y is equals to x times x will be x squared plus x times the x will be x dx. Then dx multiplied by x also will be plus x dx plus dx times dx will be dx squared. So with this we have y plus the y equals to x squared plus x dx plus x dx. That will be 2x dx, right? So that will be 2x dx. 2x dx plus dx squared, all squared. So remember to put this bracket so that the squared can cover for the x. It will not be as if you wrote dx squared. So it must be in bracket that dx is squared. So what do we do now? We need to make the y dx the subject of the formula. Therefore, it becomes the y equals to x squared plus 2x dx plus dx squared. Now, this y comes to the other side, becomes minus y. And remember the value of y from our equation 1, I mean the equation given to us. Y is directly equal to x squared. Then we can tell that the y is equals to x squared plus 2x dx plus dx squared minus x squared. Now I have minus x squared plus x squared. This cancel this, right? So I'm left with the y equals to 2x dx plus dx all squared. Dx all squared. So what do we do from here? I will need to factorize the x out of these values that I have at the right hand side. So let's take it to another page. The y is equal to 2x dx plus dx all squared. So if I factorize the x out of it, so we have the x multiplying, what do I have? What do I have here? 2x dx. To complete this, I'll just need to multiply it by 2x, so that if I open this bracket, dx multiplied by 2x will give me 2x dx. Now, plus, I have 1 dx here, so the x, so that makes it 2. You know, this is dx squared, so dx multiplied by dx will give me this. So I just factorized out. Now, divide both sides by dx. You know, we just want to have the y dx to know the change that has occurred alongside with y and x. So the x cancel the x. Now I can tell that the y dx is equals to 2x plus dx. Now, what do I do with this dx? Remember that limit was not given here. Therefore, we assume a limit for it. So